Technical issues. Not sure if you're out there. There's one watching. I think having the link would help. Maybe this will do it.
In this video, I'll show you how to set up and manage live streams in YouTube's Live Control Room. We've built a brand new stream workflow in Live Control Room that can
Okay. Apologize for the delay, whoever's watching right now. I'm just trying to find the link to share this. If you happen to have the link, you could share it here. Oh, here we go. I think we're in business now. This should work. Let's see. Okay. That should be it. Okay. Let's see. Hey Josh, I'm glad that you're watching. I shared the link. I'm just waiting for others to show up. Hey Dahlia. Oh, nice. Great. Yeah, I can only see that one person is watching this. Great, great. Oh, this is awesome. All right. We're live, so you can definitely hear me, right? Good morning, everyone. Ah, this is awesome. So, I shared a couple of things. There's access to a digital whiteboard. I'm not sure if you clicked it. So the only thing is this, I'm not really too sure how you're watching me, whether it's on your cell phone, whether it's a laptop, desktop, I really don't know. But today I'll be utilizing not only this stream, so this way I can show you the actual slides for the next chapter, but I also have a digital whiteboard that I shared. Right now it's blank. Um, you can click it. So that might be a good way to start, just to see if this whiteboard is working. Uh, let's see what we can do here. If you see this, just type it in. Type it in this chat. I just posted something on the digital whiteboard. Great, great. We are live then. Okay, very good. Very good. That's right. That's going to be our hashtag for the next few days, I guess. It's great. All right, so you had some questions. I submitted the solutions to the homework. I hope you saw that. I only see the thumbnail. So before we begin, do you have any questions with the homework? Because that is now live. I shared it in the Google Classroom. I know that some of you had issues with that. For those who submitted, thank you. For those who didn't, I know that some of you did it also through Jupyter. So I'm happy that you were able to at least submit it through one of the platforms. But going forward, let's try to submit it through Google Classroom. This way, everyone's using the same thing. Can you go over a homework question? So this is Liana. Can the homework be sent through Google Docs? Yes, Mohammed. Question number 8. Question 6, 7, and 8. So let me go over that, at least one of those, because we could be here all day doing that. But again, the solutions are posted, but I'll go over, let me see, hold on. I'm just erasing the board now. I hope this works. Yeah, it's working. All right, so I'm hoping that you can hear me and you can also see the whiteboard. Is anyone having an issue looking at the whiteboard and hearing me? All right, let's see. What was question number 6? Let me see, hold on. What was the issue with 6? Let's see. You didn't have to find the domain, I don't believe. You just had to evaluate the expressions. So is there one operation that you want to look at specifically with number 6? Because it's the solutions I presented. The solutions are shared. The last 3 were the most troublesome personally. So I'll go over one of them just in case you forgot what was that was all about. Maybe I'll go over this one. So f, hold on. So I'll go over this, f minus g, and we're going to evaluate that when that's -2. So if you remember, it's essentially both operations, or both functions. We're evaluating each separately, and then we simplify. So the original function here, again, I apologize for my handwriting. I'm using my finger. I don't have a fancy stylus, and I don't think Staples is going to open for me so that I can buy a fancy stylus. So here, we have f of -2. So that will equal 3 times -2 plus 4. And if we simplify this, we should have the following. So that's the evaluation of f of -2. So now here's the interesting thing with this whiteboard. So I can move it, but it's not going to move for you. You have to physically move it. So there's this little hand button here. I don't know how you're looking at this, but I'm pointing to the hand icon. So if you click that or touch that, then you'll have access to move the board. So I'm going to move it now to the right, or move this out of the way to the left, excuse me. So hopefully you see that. So I'm now working in this space. If anyone has an issue, please let me know. Hold on, let me see. So we know that f of -2 equals 2. -2, is that what it was? See, now I have to go back. All right, f of -2 is -2. So now we're going to evaluate g. So g, let me just go back to the work, sorry. So now it's g of -2. So g of -2, again, we're looking at the absolute value of x, but that's going to be negative. So although we have a -2, when we take the absolute value of that, that becomes 2. But since their negative is out there, it remains negative. So we basically have something like this. So now I'm directing you to follow the arrows this way. Is anyone having an issue that following along with the whiteboard? I'm taking your silence as a no. So I'm moving now. So, is the whiteboard working? Can you at least confirm that you're seeing the whiteboard, that you're moving along with me in this digital whiteboard? Are we cool with that? I just need someone to confirm. Okay, cool. Thank you. Nice, nice, nice. All right. So, we basically have this. So now we know that f of -2 is -2. And g of -2 happens to be -2. But if we're going to do f minus g, then that's going to become essentially -2 minus a -2. But we know that's the same as -2 plus 2, which just equals to 0. Any questions with that? Or is it a little bit clear at the very least? So that's number 6. And that's the process. So the only difference now is that you would be performing the operations. So in this case, it was subtraction. And I think letter A, it was addition. C, let me just look. And again, this is all in the solutions that you were given. Right, so you have g plus f of 0. We just went over f minus g of negative 2. The other one was f times g of 3. So I think in the solutions there's an error or an issue. Because in the evaluation, so if you look, so we'll do that one quickly only because in the solutions I believe I purposely left an error there. So again, follow along with me. I'm moving here, I'm moving down, let me just see. So I'm going in this direction now. Follow along. I'm going here. All right, so we just look at f g or f times g of 3. It's the same evaluation. So f of 3, we know that's going to be 3 times 3. Sorry for the handwriting. Plus 4, which is 13. And then here we have g of 3. So this is the only issue here. It's the negative or the absolute value of x or 3. We have to make sure that's negative. So again, following the arrows. I think you can also zoom out. So here, if you look here, you don't have to go crazy with scrolling. There's these plus and minuses. So if you zoom out, you get more of a view of the board. I'll show you here, just so you see. I'm not sure if it's happening on your end, but at least on my end, it zoomed out. Can someone confirm if that happened? Hold on, I'm looking. Can someone confirm that when I zoomed out, that it also zoomed out on your end? Anyone, can we confirm that in the digital whiteboard that I just used here, when I zoomed out, did it zoom out on your end? Yes, sir. Nice. Okay. No. Okay, so that's fine. So I'm just going to continue with the arrow. I don't want this to be an issue for anyone. So you could leave it at 100%. You have the independence now to zoom in or out. So that's on you. You could follow the arrows and keep it at 100% magnification. But if you zoom out, that enables you to be a little bit lazier and you can watch the whole show, if that makes sense. So, in other words, so I'm going to go down this way, you can follow along. So essentially, when we're going to multiply these two functions, that's not composite, just multiplication, so you can see the operation. This will become negative 39. So that's the only difference with what's in the homework. I purposely left that as an error, although the student or whoever's work that was they took a screenshot of, they had the correct evaluation. It was 13 and negative 3. Their final answer was positive 39, and it should have been negative 39. Is that a little bit clearer now? Or do you feel comfortable moving along to today's lesson? Waiting for some feedback, guys. Looks good. Great. Anyone else? Good. We feel a little bit more comfortable. So another way, just so that if you have confusion about domain and range, you can always use Desmos. You can graph these functions, and then that will allow you to see clearly the limitations on a domain, as well as any limitations on a range. So I've included the domains in the solutions. I believe that they are all correct. But if you have further questions, we can definitely discuss after hours, if you will, if you want to just leave me a message. I hope everyone's doing well this morning, by the way. And now we move on. So, we're looking at chapter 3. We finished chapter 2, and we're going to now start polynomial and rational functions. So, it sounds intimidating, but I wouldn't be too concerned because I'm going to walk you through this and we're going to do great together. So, let's see what we're going to look at first. So, we're looking at synthetic division. So it's kind of hard to see maybe if you maximize on your end, if you have a full screen, then you can look at these little memes. It says, I don't often divide polynomials, but when I do, I use synthetic division. You know what really grinds my gears? Learning polynomial long division before learning synthetic division. So, the positives. You already covered long division in Algebra 2. When you were preparing for your Algebra 2 Regents, that was part of the curriculum. I'm not too sure who taught you in Algebra 2. Likelihood that it was either Mr. Dang, Miss Lin, I believe. So, or maybe Miss Huang. I'm not really too sure. But one of them may have covered synthetic division. So, first of all, let me go into what the division algorithm looks like. So, this looks kind of complicated. So here it's saying some function of x is equal to g of x times q of x plus r of x. This looks like nonsense. Initially, it does. And if you're if your head is kind of spinning, I feel you. I understand why you would feel that way. But once this is said and done, you'll understand. So what we want to do is essentially divide a polynomial with many terms in the examples that we're going to be covering, it's going to be by a binomial. And what we're going to be left over with is a quotient, and that quotient may have a remainder. So that's basically what we're doing. So to simplify it, we're going to divide, we're going to have an answer. That answer may or may not have a remainder. And the thing that's going to make it tricky is that they're essentially algebraic expressions. So we'll go back to that. So I just want you to see what synthetic division looks like. So synthetic division provides an efficient process for dividing a polynomial by a binomial in this form x minus k. It's really important. I should have mentioned that the materials for this, you have them. They are in your Google Classroom. So I kind of reorganized what that looks like. So I hope you went there in your Google Classroom. So if you want to just take a look or take a pause, I'm going there now so I can walk you through. So in your Google Classroom, in the Classwork tab, you have Chapter 3 learning materials. And I believe in these learning materials, you will have access to the Chapter 3 PDF, which is the slides that you're looking at now. So if for whatever reason it's too small, you can't really make out all of the details, that slide or the slides you now have access to within this Classwork tab of Google Classroom. So if you want to take a minute to go there, to download it, so this way you can follow along, feel free to do that. I'll give you like 30 seconds to a minute to find it. So as you're doing that, is there anyone struggling to find the materials? A better question, please let me know if you found the materials. It was uploaded yesterday. They're all there. Take a look. It's in the Classwork tab. Great, great. So this is a great question. So Brittany's asking, is synthetic division the same thing as long division? Kind of. And that's what we're going to look at now. We're going to see how long division works. I feel, or I have a belief that many people don't like long division. Just think of it this way. Many people don't like to divide, period. They see a fraction and they start to freak out. So if you're comfortable with fractions, then what I'm about to show you now is a method that you can use from now until we finish this course. You're not going to be bound to using synthetic division. But once you get used to how synthetic division works, I have a feeling that you'll never go back to long division. But again, there's some conditions. The condition being that the coefficient of x must be 1. So if we go back now, I'm going back to the slides. I hope everyone found the slides. So don't forget that if I'm talking and you don't feel like interrupting me, or you're embarrassed to interrupt and you have a question, you can ask me in the chat. You could also ask each other. You can text each other if you're having difficulty finding a material, or you just need to ask a classmate a question. You have freedom to do that. Okay. But I don't think I needed to tell you that. All right. So let's see. What happened here? So synthetic division. So I'm going to jump a slide here. So here, this is what synthetic division looks like at a glance. So I just want you to process this. So you have your numerator, you have your denominator, and then it translates to something like this. So we can go to the digital whiteboard now. I'm just going to erase what I have. Let me see if I can clear the board. Hold on. All right. Just to make it very, you know what? I'm going to just go down this way. So follow along. I'm going down this way. So 10 divided by 2, I hope that you know that we can rewrite this as 2 divided by 10. So basically, we're moving away from vertical division to horizontal. So we're just rewriting the symbol for division. I hope that this isn't too much of an issue. But before we get into the mechanics, or really the nitty-gritty of this, I want you to look at what long division looked like, or when you had experience doing that. So some of you may feel very comfortable looking at this, that this does not cause any confusion, any anxiety. You're free to use that. If you remember this method, by all means, you will produce the same answer. But I have a feeling that it can be overwhelming. I'm not the biggest fan, and I'm also a fan of saving time. But the result that we'll get will be the same as if we went through this process. So what's this process look like? So if we look at the example, so let me see here. So again, I'm moving here. So I'm now in the digital whiteboard. Arrows are pointing down. I hope you're following along. So we have this example. It was 3x squared. We have minus 2x squared minus 150. And all of this is divided by x minus 4. Feel free to use long division, but I'm not going to do that. So I'm just moving this down, and I'm going to rewrite it. So how I want to rewrite this is as follows. So synthetic division will work this way. So all we care about is this k value, excuse me. So the k value in x minus 4 is 4. And what we want to do is essentially divide. Basically, we're going to represent everything that was in the numerator, but only the coefficient of the variable or the terms. So as an example, so I'm just going to go back here. So if we look, we have 4. So that's our k value. I'm not writing negative 4. I'm going to use the value of k, because if it was x plus 4, then k would be negative. So in other words, the coefficient of x squared is 3. X cubed. I'm sorry, I wrote this wrong up here, I think. My mistake. So I'm just making a correction. I'm going back. That it should be 3x cubed. My mistake. So the coefficient of x cubed is 3. The coefficient of x squared is negative 2. So I'm going to write negative 2 here. But here's the thing. So you're probably wondering where this 0 is coming from. So when we divide, we have to consider all terms, especially if we have some type of polynomial expression. So there is an x value. So I'm going to just show you here. I'm just coming down so you can see what's happening, so you can follow along. Are you still with me? Any questions so far? I have yet to divide anything. I'm just setting up the synthetic division. So, if we go down here, I'm going to rewrite the polynomial that we're looking at. So I'm just rewriting it. Okay. So, we can easily say that 3x cubed minus 2x squared plus 0x. There is no coefficient for x because it's 0. But we could include it so that this way we can clearly see a progression going from x cubed, x squared, x, and then finally there's no variable, or the constant. So we're basically expressing this in standard form. So that's why, I'm going to go back down now, going down. That's why when we have this synthetic division, we have to fill in for all of the coefficients of the terms. So we clearly have 3 as a coefficient for x cubed. We have negative 2 as a coefficient for x squared. But x does not have a coefficient. Well, I mean it does, and we're going to mention that as 0. And then we're going to add the constant or include the constant at the end. So I'm going to skip a couple of slides, so this way not to create any confusion. So here's the thing with synthetic division. It doesn't really concern itself too much with subtracting. So that's the main thing here. So when we use synthetic division, unless our new denominator, for lack of better words. So unless, I'm going to circle something here. So unless this thing here is negative, for the most part, we're going to be combining through addition. So I'm going to show you what that means exactly. So follow along now. We're going to perform or conduct some synthetic division. So let's scroll down. So what we need to do here is the following. I'm just going to erase this. So we're going to start by bringing this term down. So that's number 1. So this becomes 3. I hope you have a separate sheet of paper where you're doing all of this. And what we're going to do now is we're going to multiply what I've circled with what we brought down, which is 3. So in other words, this is going to become 4 times 3, which is 12. But now I'm going to combine this. So if I combine negative 2 plus 12, so that's what I was talking about before. We're going to be adding now going forward. Although we're subtracting, we're going to be combining through addition. So negative 2 plus 12 becomes 10. But then I have to multiply 10 and 4. So that's going to become 40. So if you want, you can think of it this way. So I'm drawing these arrows here, and this is how this is going. So it becomes 4 times 3, which gives us the 12. 4 times, I'm going to draw this here, this green, 4 times the 10, will give us the 40. Now I'm going to combine this column, 0 and 40. That's going to give us just 40. And then when we multiply 40 with 4, drawing the arrows, that's going to give us 160. And when we combine that, we're left with negative 10. So now here's the thing. This looks like nonsense right now. This looks like gibberish. We have 3, 10, 40, and a negative 10. You're not combining these values. You're not doing any of that. So with synthetic division, now I'm going to scroll down. I'm moving down. Arrows, we're going down. Sorry for all the arrows, but we're looking down. So what we need to do now, because we're dividing essentially terms that are or that contain variables, we have to put those variables back into place. So in other words, we did start with x cubed, but when you divide an x into x cubed, it really becomes an x squared. For 10, we were dividing with x squared, but when we divide an x into x squared, we're left with just x. 40, in that column, it had an x, but when you divide an x into an x, the variables disappear. And what we have left over, this negative 10, I'm just moving a little bit this way, just so that you can see what I'm about to do. I have negative 10 left over, but negative 10 out of the entire denominator, which is x minus 4. So if you look to the slide, that's essentially what I did. So the slide has it explained a little bit neater, and everything is there. So I'm now referring to the slides. You can look at what I have on the whiteboard. So we're working with two things now. So you notice that we brought down our evaluation. The 3 came down, the 10 came down, the 40 came down, and then the 10 came down as well. It should be positive 10, my mistake, not negative. I'm just changing that now. So we have to put back the actual variables. So it becomes 3x squared plus 10x plus 40 plus 10 times x minus 4, or divided by x minus 4, excuse me. So this is essentially the quotient for, I'm going to go back. I'm going back to the slide. So basically where we started. So when, I'll make this a little bit bigger too. So if I divide this here, whatever I'm highlighting, it's going to result in what's on the whiteboard. Are there any questions so far? I know that was kind of long-winded. Any questions? Okay, we're going to do another example. There's no way that I'm just doing one. I'm not that messed up. All right. I'll admit this would be so much easier if we were in a physical building, but I think today's lesson is slightly better than yesterday's. Okay. To avoid errors, use 0. So this is basically what I was talking about before. To avoid errors, use 0 as the coefficient for any missing terms, including a missing constant, when setting up the division. So let's look here. We're going to examine this second example. And I'm sorry that it gives everything away. So right now you're seeing the solution. So just focus on the top part for a second. Actually, let me see if I can do this. Hold on. So let's see. Gone. So this is what we're looking at right now. So what I want us to do. So here, I'm going to go back to my whiteboard. I'm moving down. See the arrows? I'm moving down. And I'm going to rewrite this in synthetic division format. So, first, what's going to go inside the box, for lack of better words? We want the coefficients there. And in this example, we don't have to include 0 because look at the standard form. It's going from x cubed, x squared, x, and then it stops. We can argue that 2 is the coefficient of x to the 0 power. We could argue that because what is x to the 0 power? 1. Uno. Enna, for those who understand. So, what we're going to do now, I'm going to erase this. We're going to put the coefficients in here. So, the coefficients are 5, negative 6, negative 28, and negative 2. So those are the coefficients with the constant. And then what's going to go outside, so notice here how it's x plus 2. We're now going to make it minus 2. So that's the only difference here. So when you have a denominator, so again, this only works, this synthetic division, when we're in a binomial form of x minus k, and the coefficient of x is 1. So let me write this down. So x minus k, it must be 1x. So this is important. So when we do this, almost all of our examples, the coefficient of x will be 1. Just putting that out there. So now we have this division, or this synthetic division that we have to now perform. So the first step, if you have it, amazing. If not, follow along. We must bring down the 5. So this becomes 5 here, and then we're going to continue with the multiplication. So you just have to watch out for this negative. So pay attention to that negative. So then this becomes, over here, a negative 10. So here, let me put that in here. So this is what we're looking at right now. So if you're looking to the slides, this is what you should have in front of you. So again, reiterating from what's in the slide, x plus 2, excuse me, that leads to a negative 2 in this modified denominator. So we continue combining now. So this would become a negative 16. But now we have to multiply these two together. Negative with negative becomes positive. So that should be positive 32. So when we combine this here, that leaves us with, so if we look, again, the example I'm showing you, again, so now this is in the PowerPoint. So again, just following along. So when we combine this, we should have a positive 4. And then when we multiply this again here, we're going to multiply these two, we have negative 8. And then when we combine this, again, we're adding, we're going to be left with negative 10. So I'm going to move the arrows down. I'm just moving everything down. So again, you have this flexibility. I'm not going to really erase too much here. You can always go back, zoom in and out at your will. So basically now I'm looking at 5. Let me change this. I'm looking at 5, negative 16, 4, and a negative 10. But what I need to do now is go back to the numerator. So if here, I hope you can see my cursor. Hope you can see this arrow. It's kind of big and it's hovering at x cubed. So because we're dividing essentially x into x cubed, this coefficient has to be paired with a variable that's 1 degree lower. So x cubed really becomes now x squared. So here we just have to now write all of this in standard form. 5x squared minus 16x plus 4, there's no coefficient for this value, but since we have a remainder, we have to express it over the denominator. We have negative 10 left over from our denominator, which is x plus 2. So let me just erase this negative, and we'll write it this way. So that should be our final answer. Any questions so far? I'm glad you like it, Josh. I'm happy. I listened to you guys. That's why it was very important for me to get that survey out. We don't have time to mess around. I want it to be, the best that it can be for you given the circumstances. Not just you, Josh, but for everyone. And I'm going to try to update this more and more. I'll send another survey out at some point today just to get additional feedback. All right, so let's see where we are. I hope that was a little bit clear. So I think the class ends in 1 minute. Basically, I've given you more than enough to completely finish the examples that are related to synthetic division. So if you look here in the actual PowerPoint, what you need to try on your own. If you look at the denominator, you have x plus or minus some constant, but the coefficient of x is always 1. So some of you may ask, oh, what if it's not 1? What if it's 2? So in those cases, synthetic division isn't as pretty, and in those cases, long division would be preferred. But for our discussion and what's required in this course, we're going to stick with the coefficient of being 1 for x in this case. So I'm going to end it here. Do we still have Lumen Learning due Thursday? Thank you, Leanna, for your question. So that Lumen Learning stuff, yes, because it's review. And I don't want you to lose those skills. I don't think it's too much, though. I'm going to go back and see. I don't think I assigned an overwhelming amount of content. I think it's fair, though, given what was assigned. Can we use long division for the homework? Absolutely. Absolutely. If you feel more comfortable using long division, go for it. And if you want, you can check your work using synthetic division. There are ways to check your work. But that we'll save for tomorrow because I definitely don't want to take your time. I think now the imaginative bell has gone off. Do we have to submit the work for the try on your own? So that's a good question. So let me just look here if you're still with me. Classwork, the homework for synthetic division. I mean, look here. We'll do this. This will be your homework. So this is going to be your homework for tonight. This try on your own. I think this is fair. And it'll be good practice for what we went over today. So again, I'll leave the synthetic division homework in place. That's there if you want to do it. But I'll modify it so that I'm going to include this as the primary homework. So again, for homework tonight, we're going to do this try on your own. Any other questions? Right. Yeah, so I'm going to make it clear in a post. So yes, in about, hopefully before noon, but at some point today, I'll make this the official homework. You have it now, you can do it. But this will be the homework that's going to be due for Friday when we meet again. Yes, Leanna, I will upload the new homework and then you will just submit that. So just the try on your own, Brittany. Yes, that's correct. I'm going to make it very simple for you. Any other questions? Great. So the whiteboard, I believe, will stay up. So this way you can go back and review. I hope it's not that messy. Again, it's my first time working with this, but you have the freedom to zoom in and out. I'll leave it up there for you to look at while you complete your homework. You have the slides that will help you as well. And that's it. So I hope you have a great day. Don't work too hard. Stay safe and healthy. And to be continued on Friday. And again, any questions, just send me an email. Have a great day, guys.